Okay, we are here. Finally, we are here. We will create our first ever project using TensorFlow and Keras. We will solve one basic linear regression problem. So, first of all, let us know what is a linear regression. So, let's search for it. Okay, we got a short note, we got a definition by IBM. It's saying a linear regression analysis is used to predict the value of a variable based on the value of another variable. What about Wikipedia? According to Wikipedia, in statistics, linear regression is a statistical model which estimates the linear relationship between a scalar response and one or more explanatory variables. So, in simple word, if we give one value, based on that value, it will predict the another value. So, what are we waiting for? Let's get started. We will take help of a few libraries and frameworks like NumPy, TensorFlow, Matplotlib, and Keras. So let's import all those. Import NumPy as np. Import matplotlib.pyplot as plt. Import TensorFlow as tf. If we want, then we can import the Keras or we can use from TensorFlow. So we will use from TensorFlow. Now, at this point, we will have one vector. We will create one vector. So now let's create two variables and name them x and y. And here in these two variables, we will assign some values. So first, let's assign value to our x variable. Here, let's assign one vector. And we can do that using arrange method of NumPy. So np.arrange. And we want the value from 1 till 50. And we want the step 5. Let's execute it. And test our variable, or we can say test our vector. Awesome. We can see the values here. Let's test the length. So we have 10 values in our vector. Now let's create the second vector, the y vector. And inside the y vector, we will have the same amount of values. The length will be same, or we can say the size will be same, but the values will be different. We want a gap of 10 between every values. So we can say like this, np dot arrange start from 11 and go till 110 and with a step of 10. Now let's check the vector and check the length. We can see the length is 10. But this is not the exact vector we want. We actually want x plus 10, this vector. Check the data and check the length. So we want this data. If we look closely, then we will see the pattern. So let's print this x and y together. X, y. And we can see in our vector x, the first value is 1 and the second value is 11. In the x vector, the second value is 6, and in y vector the second value is 16. So we can see clearly a 10 difference. Now if we want, we can see the linear relation using the matplotlib, and we can do that easily. We can simply say tlt dot scatter, and we can say x and y, and we can see the linear relationship between x and y. So now what do we want? Now we want to create one model using neural network, using artificial neural network. After creating the model, we will train our model using our data, using these two sets of data, the x vector and y vector. Our model will find the relationship between these two sets of data. And after training our model, if we give any number to our model, then it will predict perfectly, not accurately actually, not the exactly, but very closely it will predict the number. Based on the input, it will give the output with near about a difference of 10. Because our both vector has a relationship of 10 gap. Let's create our first model using Keras' sequential API. And we can say tf.keras.sequential and assign it in some variable. I'm naming this variable model, or we can say linear model, or we can say linear regression model. So we have created the instance of our model, and now we have to add layers to our models. So we can say linear regression model dot add, and here we can pass the layer. We will use the dense layer, the Keras' dense layer. So tf.keras.layers.dense, and inside the constructor argument we will pass the number of neurons. Let's say 10 for now. And if we want, then we can name it. We can name our layer. We know we need one input layer and we have 10 set of data. So let's name it input layer. Name. And then we need one output layer. So here we can go and add again linear regression model dot add. Again we can add one dense layer, tf.keras dot dense, layers dot dense, and for output we need just one neuron, and we can name it output layer. And we're done with our layers and neurons. Now we need to compile this model. We have perfectly created the model with layers and neurons. Now we have to compile the model, and we can do that using the compile method of Keras. So we can say linear regression model dot compile. The sequential API of Keras has the compile method, and it takes a few values as constructor argument. First one, we have to pass the loss, and this is one required value, a required argument value we need to pass. We can say loss and some value, and then we have to pass optimizer, again some value, and finally we have to pass matrix and some value. First of all, let us understand what is loss. In machine learning or deep learning, it's called the loss function. The loss function is used to find error or deviation in the learning process. Keras provides a quite few loss functions in the loss module, but we will use mean absolute error. And we can pass MEA, the short form of mean absolute error. So let us understand what is a mean absolute error. We can simply search for it and check the official documentation. We can say mean absolute error Keras. Okay, this is for matrix, but we need for loss function. So we can say absolute mean error Keras loss function. And we can see this. So what does this do? It computes the mean absolute difference, what we just knew a few minutes ago, a while ago, that loss function is used to find error or deviation, means difference between labels and predictions, means between two set of values in learning process. So it computes the mean or average of absolute difference or deviation, what we say, between labels and predictions, means between actually two values, two set of values. In the learning process means in training process, which we will look shortly. So let's get back here. Loss is MEA, mean absolute error. Okay, sorry, MAE, mean absolute error. And matrix also MAE, mean absolute error. And it will be one vector. So MAE. What is this MAE? What is this mean absolute error? Let's check the documentation, the official documentation. You can go back here in this tab, go back, again go back, and here we can see it's saying computes the mean absolute error between labels and predictions. So let's compare these two again. Mean absolute error Keras loss function and mean absolute error Keras matrix function. In matrix function, computes the mean absolute error between labels and predictions. Compute the mean absolute error between labels and predictions. And in loss function, computes the mean absolute difference. So in loss function, we compute absolute difference, and in matrix function, we compute mean absolute error. Get back to our linear regression model. After this, we need one optimizer. So what is an optimizer? The optimizer in machine learning or deep learning is used to optimize the learning process based on loss function and error matrix. And there are a few optimizers, but for now we can use SGD, stochastic gradient descent optimizer. So SGD, and let's compile it. Maybe we will get an error, that doesn't matter, but let's compile it. Okay, we didn't get an error, so that's a good news. Now it's time to train our model, and to train our model we need to call the fit method. We can say linear regression model, linear regression model, the name of our model, dot fit, and it takes three required arguments. At first argument it takes the x vector, at second argument it takes the y vector, and at third argument it takes number of epochs. Epochs is the time lapse. Let's say we want 10 epochs and we are ready to train our model. So 3, 2, 1, 0. Hit enter. And we got an error finally. What is this saying? It's saying input 0 of layer input layer is incompatible with the layer expected something something something. It means we need to define input shape. So, and we need to define at our input layer. We can say input shape and pass our shape. What is our shape? We want to pass some single value. Like if we pass 10, it will say 20. It will predict 20. If we pass 15, it will predict 25. So it's a single value. That's why we can pass 1 here. Execute it and we should get an error. Yes, we are getting an error. What is it saying? It's saying keyword argument not understood input shape. So let's reinitialize it, our model, then execute it again. Again we are getting this error. So the error is very silly. Actually, I misspelled it. Input. And this time we are getting one interesting error. It's saying all layers added to a sequential model should have unique names. The reason is we have executed this code once. So it has created one layer named input layer. Now when we are trying to execute it again, then it's trying to create another new layer but with same name, input layer. To get rid of this error, we have to just recreate this one. Recreate the instance of this model again. So new instance, execute it, execute this compilation, compile is done, and ready again. 3, 2, 1, 0, action. Finally, we have trained our model successfully. So let's pass one value here. Let's call linear regression model.predict. As we have matrix, so we have to pass the value as matrix. Let's say 9. Based on the data we have passed, it should predict 19 or near about 19. So execute it. And we can see it has expected the same value. It's very bad. The bad model we have designed. This model is very bad. Okay, and also we can see the loss. The amount of loss is very high. The error matrix also is very high. How can we improve this model? Let's do that in our next lecture. But before that, if you love it, hit the subscribe button, leave some great comments, give me one thumbs up, and don't forget to hit the bell icon to get the instant notification whenever I upload new exciting videos. See you soon in next lecture.